Let's try a problem together that'll help you get ready for the AP Calculus exam. The concepts covered in this particular type of practice problem show up between 9 and 13% on the AP Calculus AB exam. If you want to try the problem first on your own, go ahead and pause the video now. Otherwise, let's go ahead and tackle it together. Alright, so the point, -2, 4, lies on the curve in the xy plane given by the equation f of x times g of y is equal to 17 minus x minus y, where f is a differentiable function of x and g is a differentiable function of y. Selected values of f, f prime, g, and g prime are given in the table below. What is the value of dy dx, or the derivative at the point -2, 4? Alright, let's start by looking at our original equation. Alright, so if this is our original equation and we want to find the derivative, let's go ahead and take the derivative of both sides of the equation. So we're going to have to use implicit differentiation here. On the left side of the equation, notice how we have a product of two functions, so we're going to have to use the product rule. So for the left side of the equation, let's go ahead and take g of y and multiply that by the derivative of f of x. We can go ahead and just call that f prime of x. And let's go ahead and add the product of f of x multiplied by the derivative of g of y. And that's going to just be g prime of y. But don't forget, if we are taking the derivative of something with a y, we also have to go ahead and multiply this by dy dx. There's that chain rule. Now for the right side of the equation, let's go ahead and just find the derivative of each of these pieces. The derivative of 17, which is a constant, is just going to be 0, so we can go ahead and write 0. The derivative of this minus x is going to be minus 1, and the derivative of this minus y is going to be negative dy dx. Alright, so we just used implicit differentiation, and while we did so, we also used a chain rule over here and over here. And so let's go ahead and now just rearrange this equation so we have dy dx isolated by itself, or on the same side of the equation first at least, right? I'm going to go ahead and add dy dx to both sides so I can get this to the left side of the equation. And once we have both dy dx's on the left side, let's actually go ahead and subtract this g of y times f prime of x so that we can move it to the right side of the equation. Let's go ahead and do that. Okay, so we just reorganized a little bit and we got both the dy dx terms on the left side of the equation. Let's go ahead and factor it out as a common factor on the left side. And if we do that, we're going to have this equation right here. Alright, perfect. Now that we have this dy dx just one time, it's being multiplied by this expression over here. So let's just go ahead and divide both sides by this so we get it to the right side of the equation. If we go ahead and do that, we're going to get that this dy dx is going to be equal to this expression over here over this expression. So here we factored, and here we just kind of reorganized again to get dy dx alone. Now that we've isolated dy dx, let's go ahead and evaluate this expression to the right based on the information that we have in our table over here. So let's go ahead and take our dy dx, and let's go ahead and evaluate it at the given points here. We have our numbers of -2 and 4. I'm going to go ahead and just substitute those values in, and let's go ahead and use this information. Substituting in, we're going to get something that looks like this. Now let's just go ahead and make some more substitutions. So for this g of 4, let's go ahead and substitute in 5. Then for this f prime of -2, let's go ahead and substitute in a +4. For f of -2, let's go ahead and substitute in the value 3. And then for g prime of 4, let's go ahead and substitute in 2. Substituting in, we're going to get -1 minus g of 4, which you know is 5, multiplied by f prime of -2. We said that's going to be +4. And this is going to be all over 1 plus. Now f of -2 we said was 3. And then g prime of 4 we said was equal to 2. So in the numerator here, -1 minus 20 is going to be -21. So that's going to be our numerator. And then in the denominator, 1 plus 6 is going to be 7. So our final answer here is going to be -3. Looking at our answer choices, I think we're going to have to go with C here. This would be our answer.